Hello everyone, welcome back to 14C. We're gonna find some like a simple size today. Um, so we're gonna using CAS calculator basically start from now to next chapter and onto chapter 17. Um, the probability of winning the prize in the game of the chance is 0.48. So let's start with examples. So first question they're asking, what's the least number of games they must be played to ensure that the probability of winning at least once is more than 0.5? Okay. So first thing first, we're gonna try to win in each game and the same each time the game is played. So as we know, this is binomial distribution, which is the this is a independent and then the 3 points you need to figure this out. Y is the binomial distribution and the probability of the success. So P equal to 0.48. Now what we do is so we at least one or more than, so which is probability of x greater than equal to 1 is greater than 0.95. So more than 0.95. Yeah. So we basically can say is 1 minus the probability of x equal to 0 is greater than 0.95. And another way to say probability of x equal to 0 is less than 0.05. So now what we do, we can try to figure this out. So hopefully you still remember how many games we play. We don't know, so we say n 0, 0.48 to the power of n, and then 0.52 is 1 minus n. So this is what we're gonna try to figure out. Now we can say use the CAS calculator, and we can use 0.52 to the power n less than 0.05, because we know probability of x equal to 0 is equal to 0.52 to the power n. So now we can use the sort functions. So we can do log e 0.52 n is less than or equal to log e. So we're using the same base to figure out n equals. Now we can use sort function. So n and log e 0.52 is less than log e 0.05. Now we do n greater than log e 0.05 divided by log e 0.52. And approximately equal to is the CAS, and approximately equal to 4.58. Yeah. That means like the game must be played at least 5 times to make sure the probability of winning at least once is more than 0.95. So that's it. Also, we can use something with the calculator. I will show you how we do the step by step with this question. And also, we're gonna try to find the inverse the binomial. And now you can understand how we're gonna do this question. Yeah. So now what we do is we're gonna try to figure this out. Question B. What's the least number of the games that play ensure the probability of winning at least twice and more than 0.95? This question we're gonna require smallest value. Now what we do is um, probability of x greater than or equal to 2 is greater than 0.95, and that means probability of x less than 2 is less than 0.05. And now what we do is we're gonna do n 0, so 0.480 and 0.52n plus n to 1, 0.48 to the 1, 0.52n minus 1. And that equal to 0.52 to the power n plus 0.48 n times 0.52 n minus 1. So now what we do is the value of n, so we can try to figure this out. So because that's less than, so 0.52 to the power n plus 0.48 times n times 0.52 to the power of n minus 1 less than 0.05. We're gonna use CAS calculator, try to find out when it's equal to 0.05, and you can say n equal to and approximately equal to 7.798. And that means we must be play and approximately need to play 8 games. Yep. So this is how you're gonna try to do with inverse binomial distribution. Hopefully that makes sense. And I will see you guys next time.